Bonjour, François Letourneau from GSC Quebec. I'm here to present you the Groundwater Information Network. And you'll see there's an emphasis in the title in the renewal of the GIN project. In fact, some of you might know about GIN. It's been available since a lot of years. We are currently in the phase of renewing all the infrastructure and all the application of GIN. Unfortunately, as I'm now talking, it's not yet publicly available. So instead of just showing what will be coming in the next coming months, I will also give you some interesting information about the background of GIN. There's a lot of science data standards behind it, and this is a very great opportunity to talk a bit more about the background of this whole project and let you know how interesting collaborations also can be defined using this project. So, just as a summary, I'll be reviewing some historical perspective of the project. I will showcase some past key results for GIN, and we'll talk, of course, about the modernization project, which is currently ongoing. And yes, of course, there will be a short demo of the new system that will be presented in the application during the presentation. So GIN for this current fiscal year is a shared responsibility between two teams working at the Geological Survey. So we have the GIN core team, which is responsible for the development of the application. We are responsible also to integrate groundwater data from various sources, work on the development of standards. So I'm the technical lead of the project. I've been appointed about 18 months ago. But I've been working for GIN since a lot of years, mostly in the data integration and metadata part of the project. And we have at the other end of the spectrum the Digital Geoscience Group, which is responsible to help us to migrate the whole application on the cloud platform, which represents a real challenge on our case. In fact, we are beating the path at the GSC. We're amongst the first project to go live on the cloud. So there's a lot of technological barriers, security assessment that needs to be conducted, and this is why also there's been some delays in the upgrade of the application. So at the GSC, we're typically working on a 5-year cycle time frame for our project. So we are currently in a 24-29 time frame project for GIN. So during that period, the primary objective is clearly to migrate GIN to the modern cloud platform and fully modernize the application. And as a second objective, we are looking to maintain the existing partnerships between the various partners that are providing groundwater data, and also identify new partners and data sets that can be useful. And it's very interesting to be present at this conference today to see the type of data that you are capturing and also that you are managing in your system. That would represent additional opportunity for us to bring it online and have ways to distribute and disseminate this important new groundwater data. In terms of key activities, we will modernize the online access to Canadian groundwater data with groundwater data from NRCan and also external partners. Maintain and expand the current groundwater data sets from GSC programs. So most of the programs working on the environmental geoscience program, there's a lot of groundwater data information that needs to be imported into GIN. And also we would like to monitor, advance, and adapt new groundwater data standards. But on that part of the project, we have a limited outreach that is possible. And then until GIN is moved to the new cloud platform, it can still be accessed using this address. It's available online. We had a few issues past 2 weeks regarding our certificate, but now it's back on track. So you can access the platform and work with the various tools to get access to groundwater data. In terms of historical perspective, well, GIN takes its roots more than 25 years ago. At the beginning of the century, there was a lot of studies, some conducted by IAH, other by the Senate of Canada, that states that groundwater data as a whole was hard to find. There was a lot of discrepancies based on the various data sources, and it was because of that difficult for the user to use it. There was definitely no national view about groundwater data. That was clearly lacking. So a series of recommendations have been proposed, so consolidating the data by providing an online access, provide more and better standardized data, and this eventually leads to the creation of the National Groundwater Database, which is a part of GIN. In terms of the foundations of GIN, we were the data management and delivery system for the groundwater geoscience program of the GSC. We have defined partnerships with provinces and territory throughout the country to expose groundwater levels and water wells throughout the country. And also we brought about 30 key Canadian aquifer assessment data inside GIN, delivering a lot of information about the various groundwater themes that were available. At the same time, we've developed standard-based data delivery system and have set collaboration with international partners to enhance data delivery systems. In terms of some numbers you see on the portal for the fiscal year 23-24, these are the approximate number of users that are going to GIN. From a national perspective, we have worked with multiple partners, Canada One Water, the Permafrost Information Network, Federal Geospatial Platform, Geo.ca, to provide, through our system, to expose additional groundwater data. From a continental perspective, we also work with the USGS Groundwater Monitoring Network to link together the water level monitoring network data from US with the Canadian water level monitoring system. And we were able to jointly provide a coherent and homogeneous report of the groundwater level. And also on a global scale, we had partnership with UNESCO to participate in their monitoring network initiative, as well as working with WMO and IDRAC on global scale reports. Some key results from past project cycle is one interesting one is the data product specifications. Might wonder what it is specifically, but in a nutshell, a data product specification is simply a specification that defines a data set and provides information about how to create it, how to supply it, and how it can be used by another party. In other words, following the specification would allow a partner organization to provide, let's say, some hydrogeological information that would be compatible with our system. So it was defined in close collaboration with NRCan hydrogeologists, superficial geologists, and information managers. And through the definition of these product specifications, we were able to provide a set of 16 different types of groundwater data layers that are standardized. And it helps a lot to have a better integration and to boost the collaboration between some partnerships. Inside the DSP, there's a definition of the data structure, the attributes, and also the definitions of all the features are there. And it's available in both language, in both English and French. These are the 16 groundwater layers that are defined by the DPS. So we have hydrological units, recharge, groundwater level, samples, flow, and so on. So it's very extensive and it covers a lot of the interesting data layers that GIN can be providing. Let's move on about the data delivery system, just to give you an idea of how GIN is working in a very high level. We have the various data sources that are available, so legacy aquifer from the groundwater data, and also new data that is coming from environmental geoscience program. So these data sets are typically integrated into the national groundwater database. We are following the DPS to facilitate the data integration. And for the water wells and water levels that are provided by the province and the territories, we have an integration layer that allow us to transform the data and then provide a unified view over the country with the various water wells and water level elements. We have different ways to disseminate the information by supporting recognized international standards like WMS, WFS, also Groundwater ML, which is a sub-product of GIN. And all those platforms, GIN, FGP, OSDP, Geo.ca, can access our data and reuse it because we are providing those open standards elements. In terms of another interesting result, we have the groundwater modeling language, which is based on the GML. It's an OGC standard. It defines all the scientific domain of the hydrogeology, so the wells, the aquifers, water quantity, and this is all defined using conceptual models. So within the documentations, all the features are well described. The relationships between them are very clearly explained. And there are also XSD schemas, implementations in XML to guide future users about how this groundwater ML output can be used to work and transmit groundwater information data. Now, if we are moving forward in terms of the new GIN project that is currently under development, GIN by itself has suffered by a lot of aging infrastructure, aging technology, and some HR challenges. So in order to maintain the system useful and manageable by our team, we needed to try to simplify the global scope of the application. So one of the things was to try to simplify the user interface, to remove some services that required a lot of maintenance. And that was achieved using what we call a minimal viable product operation, where we identify the key components of GINs that should be maintained over time in order to provide a good usage of the groundwater data. So the MVP helped us to identify the core functionalities of GIN. So of course we have a map viewer that is using standard-based data. So we are also able through that map viewing environment to connect to external data sources and provide the data source in our data environment. We also have the data dashboard, which is very interesting as it provides information about advanced groundwater related data. We are showcasing well logs, water level diagrams, and advanced chart visualization. It is complemented by a very comprehensive set of metadata that helps to provide information about the original data sources that is disseminated through GIN. And there's a lot of other tools like an advanced search tool that helps the user to get to the appropriate data, and a lot of web and GIN services allowing us to disseminate the data. This is very quickly the high-level architecture. I will not go into details. This is based mostly on cloud infrastructure. We have a development environment and also a production environment. This is currently going under security assessment. So we are hoping to be able to go live online by late March, early April, given that we are receiving the approval from the security assessment currently under that. So a quick glimpse about the new portal that we are building. So basically, we try to simplify the interface, to reduce the number of clicks and operations to get access to the data. We also borrow some ideas from new platforms like Geo.ca, which is integrating a lot of geospatial data. And that was the guideline for us to have a sleek and modern interface, being able to provide a quick access, a quick and easy access to groundwater data. So if I'm going here, just to showcase this example, it should move, yeah, so a short video that shows the interactivity of the map legend builder. So we have a list of available layers. It's described on the right by basic metadata. And then clicking on the point, we are opening the query form. And then in that case, with the map viewer, we are showcasing some information about a water well. There should be the water log visible below the map. It was not ready when we did this quick video. But on the left, you see that there's a direct access to the download formats. So we are bound to open data formats, GeoJSON, GeoPackage. Those are all the ones that are easily accessible in open GIS environments like QGIS. And following that philosophy, we are giving a real open access to groundwater data. We have also a dashboard for boreholes, featuring information about the depth, the well log, the geological setting surrounding the borehole. So if I remember well, we have about 1.5 million well records inside the system. So for each of those records, we are providing an in-depth information that is available through this interface. And for each of those data records, it's still possible to get the access to the raw data by clicking on the export buttons on the left. And there's also metadata here that will describe in depth the layer that is being currently accessed. The metadata is fully compatible with the ISO 19115 standards and with the HNAP also with the HNAP format for integration into geo.ca. So we are, in that case, following the international standards for metadata, and we are providing a good overview of the information beneath. Finally, something interesting, as we are providing web services to get access to the data. So this is an example here of using the ST API connectivity feature of GIN. ST API is an OGC specifications that allows a query to be sent to a server, and then you get back, let's say, water levels with the time series. This is possible to use the GIS to connect directly to the service provided by GIN. So in that case, we are showing an integration of the ST API inside QGIS. So that means that you would be able to connect to GIN using the ST API plugin, which is available free as a free plugin, and retrieve the information, and then eventually you would be able to perform advanced analysis using that data. So it's not just a data visualization system, nice maps and so on. We are also providing dynamic access to the data. So these are very quickly the orientations that we are looking to develop within the tool. One of the tasks following the online presence of the new GIN will be to restart the partnership collaborations with the provinces and territories, and also with conservation authorities that are collecting very interesting information. So in any case, you can reach out if you have questions. Here's our email addresses. We would be really happy to chat with you. And well, thank you for your the opportunity that we have to present the system to the audience. Thank you.